First of all, I welcome all the students and the participants who are attending this live lecture. Today in this live lecture, we shall discuss the next examples on the Laplace transformation. Actually, the total examples of the Laplace transformations are based on the basic properties of the Laplace transformation. Now our aim is to solve the problems. Yesterday we have seen one problem. Do you know? आवाज येतो का रे? हॅलो स्टुडंट्स, आवाज येतो का? पूनम भंडे, आवाज येतो का? ठीक आहे. Yesterday we have seen the problems based on this. What is that problems here? Integral from 0 to infinity t cube into e raised to minus t sin t dt which is equals to 0. काल काही हा प्रॉब्लेम विद्यार्थ्यांना शेवटी लक्षात नाही आला म्हणे, म्हणून मी परत एकदा थोडं रिवाइज करतो. ऍक्च्युअली we have to show that integral from 0 to infinity t cube into e raised to minus t sin t dt which is equals to 0. Suppose that we have to consider f of t is equals to t cube into sin t. That means we can use the Laplace transformation, standard definition for the Laplace transformation. If we consider this here f of t, one minute, if we consider this f of t, then we can use t cube into sin t, then we can use the Laplace transformation for the standard formula e raised to integral from 0 to infinity e raised to minus pt into f of t dt. So we have to use this formula. For this purpose, we have to consider t cube f of t is equals to t cube into sin t. That means t cube into sin t. We know that Laplace transformation of sin t is 1 upon p square plus 1. Now our aim is to find out the Laplace transformation of t cube into sin t. And here we have to use this formula, 14 number formula, Laplace transformation of t raised to n f of t, we can write minus 1 raised to n dn by dp raised to n of capital F of p, where capital F of p is a Laplace transformation of small f of t. For this purpose, we have to calculate the Laplace transformation of t raised to 3 sin t. In this case, n is equals to 3, therefore minus 1 raised to n means minus 1 raised to 3 d3 by dp cube of 1 upon p square plus 1, which is the Laplace transformation of sin t. Then that means minus 1 cube is again minus, and d3 means we have to calculate 1 by 1 third order derivative. We have to calculate first order derivative. Here first order derivative, keep the second order derivative as it is. In this way we can obtain first order derivative, then we can obtain, this is the first order derivative, 2p divided by p square plus 1 bracket square. Then again second order derivative, which is divided into the first order of first order. Then again we have to calculate the derivative of this term, third time derivative of this term, that is 2 minus 6p square divided by p square plus 1 bracket cube. By using division rule, we will get the third order derivative in this way. That means Laplace transformation of t cube into sin t is equals to 24p in a bracket 1 minus p square divided by p square plus 1 bracket raised to 4. Now here we are going to explain according to the definition of the Laplace transformation. What is that? Laplace transformation of f of t is equals to integral from 0 to infinity e raised to minus pt into f of t dt. So Laplace transformation of f of t means t cube plus sin t. So Laplace transformation of t cube into sin t, which is equals to integral from 0 to infinity e raised to minus pt into f of t means t cube sin t dt. We have written here in deep statements, because in the last lecture some of few of the students who were not understanding completely this last step, so I am going to revise this step. Now keep this left side, keep this term on left side as it is, and we have calculated Laplace transformation of t cube plus sin t from equation 2, 24 minus p 1 minus t p square divided by p square plus 1 bracket raised to 4, bracket raised to 4. But actually we have to calculate integral from 0 to infinity e raised to minus t into t cube sin t. That means in place of a minus p we have to write, in place of p we have to write 1. So putting p is equals to 1, then we will get integral from 0 to infinity e raised to minus t into t cube sin t dt, which is equals to 24 into 1 minus 1 minus 1. In place of p we have to put 1. So 1 minus 1 divided by 1 plus 1 bracket raised to 4. That means 1 into 1, 1 minus 1, 0, 24 into 0 means which gives 0, and hence proof. This is a required proof. Okay. Now we shall move towards the second problem. What is that second problem, students? Find the Laplace transformation of f of t is equals to sin ht divided by t. Is it okay? Sin ht divided by t. Now you student, you tell me, what is the Laplace transformation of hyperbolic sine function? Ht here is, h is known as a hyperbolic. Actually there is another formula which confuses with this formula, sine of at. Who can tell me what is the formula for Laplace transformation of sine at? चला, जे स्टूडेंट ऑनलाइन आहेत ते सर्वांनी आन्सर लिहिणं गरजेचं आहे. What is the formula for Laplace transformation of sine at? So what is that? Who can tell me? हा चला रे, आपल्याकडे फॉर्म्युला झालेला आहे. व्हॉट इज द फॉर्म्युला फॉर साइन एटी? सी दिस, देखो अभी साइन एटी मीन्स a डिवाइड बाय t स्क्वायर प्लस h स्क्वायर, a डिवाइड बाय p स्क्वायर प्लस a स्क्वायर. But you don't confuse this a and h. If we consider here in this case a is a h, then we will get the result sin ht is equals to h divided by p square plus h square. But that is a completely wrong, because this function is a trigonometric function, sine function, and this function is hyperbolic function. Here h is a stand for hyperbolic, so you don't confuse these two formulae. लक्षात ठेवा, आपण बाकीच्या नंबरसाठी a कन्सिडर करतो. sin 3t, sin 4t means a is 4, sin kt means a is k, but sin ht means here is, in this case a is not h, because sin ht is a completely hyperbolic function. So don't confuse with hyperbolic function. So according to the hyperbolic function we have to write Laplace transformation of sin ht is equals to 1 upon p square minus 1. But we have to calculate sin ht divided by t. Laplace transformation of sin ht divided by t. So there is another theorem. What is that theorem? Laplace transformation of sin f of t. Actually, what is the, actually here we have to write the formula or theorem. Laplace transformation of f of t divided by t, which is equals to, sir, hello sir, हा हा नाही, आता भागून घ्या, माझं थोडं चालू आहे. किती वेळ लागेल तुम्हाला निघायला? बरं, मग ते दरगड सरला फोन लावा ना तुम्ही. ओके ओके. नाउ See this, what is the Laplace transformation of, according to the theorem, we have to write integral from 0 to, p to infinity, capital F of p f of u du. This is a theorem which we have studied already. We have studied this theorem. Okay, so now we have to consider, we have to solve, we have to use this formula. Suppose f of t means sin ht, and capital F of u means, Laplace transformation of small f of u or small f of t. Okay, there is no problem. So according to this, here capital F of u is the Laplace transformation of small f of u or small f of t. Okay, now integral from 0 to infinity, 1 upon, here in this case, suppose this is f of p, capital F of p, say, then capital F of p is 1 upon p square minus 1. Then capital F of u means 1 upon u square minus 1 du, because we have to take this integration with respect to u, and lower limit is p. Lower limit is p, so we have to write the integral function in the form of capital F of u. You don't write in the form of capital F of p, means 1 upon p square minus 1, because its lower limit is p. So we have to change the variable of a function, that is capital F of u du. So compare this, capital F of p is equals to 1 upon p square minus 1. So capital F of u means 1 upon u square minus 1 du. So integral from 0 to infinity, you know that u square minus 1 we can write in the factorial form. How we can write? P plus 1, u plus 1 into u minus 1. Again we have to solve this, divide by 2, multiply by 2. Now our aim is to solve this integration by the factorization method. So divide by 2, multiply by 2. So integral from p to infinity, 2 divided by u plus 1 to u minus 1. Now 2 plus, adding u, subtracting u. So 1 by 2 integral from p to infinity, 2 plus u minus u. Again these two we can write plus 1 plus 1. So u minus u plus 1 plus 1. This 2 is divided into the plus 1 plus 1. Now make the bracket u plus 1. So first bracket will be u plus 1 minus, second term is minus u plus 1. Take out a minus common, therefore we will get the second bracket in the numerator minus in a bracket u minus 1. Now separate this denominator. That means u plus 1 divided by u plus 1 into u minus 1. Then what will happen? U plus 1 get cancelled. The first factor will be 1 upon u minus 1. Similarly, we can separate this denominator for second numerator. Then u minus 1 will be get cancelled. The remaining term will be 1 upon u plus 1. So now apply the integration. Integration of 1 upon u minus 1 is log of u minus 1, minus 1 upon u plus 1 is log of u plus 1 from p to infinity. So log of m minus log of n, according to the formula for logarithm. So log of m minus log n, that will be written as a log of m by n. Log of m by n. So log of u minus 1 divided by u plus 1, lower limit is p, upper limit is infinity. Now our aim is to how to find out the upper limit of log of u minus 1 divided by u minus 1. If we keep, see this, if we keep upper limit directly, then what will happen, student? Log of u minus 1 means infinity minus 1 divided by infinity plus 1 means infinity by infinity, and you know that infinity by infinity is a meaningless term. So you don't use this. Now how we can use this? Our aim is to find out the upper limit. So limit u tends to infinity log of u minus 1 divided by u plus 1. Now our aim is to find out upper limit. It is lower limit is p. It is possible to find the lower limit for this function easily, but our aim is to find out the upper limit. How we can write here? Log of. Now take out a common u, means 1 minus 1 by u, divide by, again take out a common u from denominator, 1 plus 1 by u. This u will be get cancelled. Now put the limit. What is the remaining term? Log of 1 minus 1 by u divided by 1 plus 1 by u. Now we can use limit here. What is the limit? Limit u tends to infinity. So 1 by infinity means 0. Log of 1 minus 0 divided by 1 plus 0. If we apply limit, as a limit u tends to infinity, then 1 upon u tends to 0. So log 1, we can write here log 1. Now you tell me, student, what is the value of log 1? Log 1 is 0. So we have taken directly the value of upper limit when u is equals to infinity is 0. Directly we have written here 0. But these are the steps which gives a result 0 when we put upper limit u is equals to infinity. That means actually we have to calculate the value of upper limit by limiting position, by limiting condition, that goes to 0. But here we have written directly 0. But how we get a 0? These are the steps which shows the limit, upper limit of a given function, which is a 0. Minus lower limit, you can keep lower limit directly as a p, log of p minus 1 divided by p plus 1. Log of p minus 1 divided by p plus 1. So 0, again log of minus log of p minus 1 divided by p plus 1. You know that minus log of a plus b, then we can write plus log of b by a by b, minus log of a by b, that means log of b by a. In this way we have converted this minus 1 by 2 log of p plus 1 divided by p minus 1, and this is the required proof or required answer of f of t is equals to sin ht divided by t. डू यू अंडरस्टँड? समजला का रे प्रॉब्लेम तुम्हाला सर्वांना? समजला का? Same problem. Now our aim is to find out the Laplace transformation of sin t divided by t. This is the problem. Laplace transformation of sin ht divided by t. Again we have to find out the Laplace transformation of sin t divided by t. What is the difference between first problem and second problem? In the first problem we have used, in the problem on number 10, we have used hyperbolic function sin ht. Here in this case we have to calculate the Laplace transformation of trigonometric function sin t divided by t. Now we have sin t is equals to 1 upon p square plus 1. So Laplace transformation of sin t divided by t, which is equals to integral from, same as like a previous example, p to infinity f of u du. Here we have to consider, suppose this is f of p, say. So f of u means we have to write this function p in the form of u. What is that f of u? F of p is, capital F of p means 1 upon p square plus 1. So capital F of u means 1 tan inverse of u by 1. Now keep the upper limit and lower limit. Tan inverse infinity minus tan inverse p. So tan inverse infinity means pi by 2 minus tan inverse p means as it is. Now there is one formula, pi by 2 minus tan inverse theta, that can be written as a cot inverse theta. By using this formula, we can write pi by 2 minus tan inverse p means cot inverse p. Again, there is one formula, cot inverse x. Then we can write in the form of a tan inverse. So it can be written as a tan inverse of 1 upon x. This is another formula. So cot inverse of p, we can write tan inverse of 1 upon p. Hence, we get a result, Laplace transformation of sin t divided by t, which is equals to tan inverse of 1 upon p. Tan inverse of 1 upon p. Okay, so it's good. Now next problem, our aim is to show that, next we have to show that integral from 0 to infinity e raised to minus t into sin t divided by t dt, which is equals to pi by 4. We have to prove this result. So let f of t is equals to sin t divided by t. Suppose that f of t is equals to sin t divided by t, because here again we have to use the Laplace transformation definition, integral from 0 to infinity e raised to minus t f of t is equals to Laplace transformation of f of t. Same. So we have to consider f of t is equals to sin t divided by t. Again, we know that Laplace transformation of sin t is 1 upon p square plus 1. Laplace transformation of sin t divided by t already we have calculated in the previous example. इथं आपण कॅल्क्युलेट केलेलंच आहे ऑलरेडी, तेच इथं डायरेक्ट घेतलं. Already taken, this is taken from previous example. So Laplace transformation of sin t divided by t is equals to tan inverse of 1 by p. Already we have calculated this. These are the steps. So it is not necessary to write in the detail. So Laplace transformation of sin t divided by t is equals to tan inverse of 1 upon p. Now according to the definition of the Laplace transformation, what is that definition? Integral from 0 to infinity e raised to minus pt into f of t dt, which is equals to Laplace transformation of f of t. But we know that f of t means we have considered sin t divided by t. So integral from 0 to infinity e raised to minus pt sin t divided by t dt is equals to tan inverse of 1 upon p. Now here we have to calculate e raised to minus t, means in place of p we need 1. So keep or put p is equals to 1, then we get integral from 0 to infinity e raised to, in place of p put 1, so e raised to minus 1 sin t divided by t dt is equals to tan inverse of 1 by 1 means pi by 4 and hence proof. अशा पद्धतीने हा रिझल्ट प्रूव्ह होतो. समजतंय का रे? काय अडचण आली तर विचारा. Same problem, you have to calculate, prove that Laplace transformation of e raised to 3t into sin 5t divided by t, which is equals to tan inverse of 5 divided by p minus 1. Tan inverse of 5 divided by p minus 1. Okay. See this. Actually, this is a proof. Laplace transformation of e raised to 3t sin 5t divided by t, which is equals to tan inverse of 5 divided by p minus 5. Now suppose that f of x is equals to sin 5t divided by t. Now Laplace transformation of sin 5t is equals to 5 divided by, according to the standard form of a Laplace transformation of sin at, a divided by p square plus a square. In this way we can write sin 5t means 5 divided by p square plus 25. Do you understand this, students? चला रे, जे प्रेझेंट आहेत त्यांनी एकदा परत प्रेझेंट टाका, हाय टाका बरे, मला पाहू द्या कोण कोण ऑनलाईन आहे. So Laplace transformation of sine phi u t divided by t, which is equals to, again by the theorem, integral from p to infinity capital F of u du. But in this case, capital F of u means what? Capital. This is a capital F of p. So in this equation, we can write in place of p as u. So this is u, this will be u. So capital F of u means 5 divided by u square plus 25. So we can write this. This will be capital F of p. Then you will betterly understand how we'll get capital F of u du, the value in the form of u. So integral from 0 to infinity 5 divided by u square plus 25 du. कदम फक्त आताचीच प्रेझेंटी घ्यायचं स्टुडंटच्या. So integral from 0 to infinity 5 divided by u square plus 25. Now our aim is to solve this integral. 5 is constant, so you can take out of integral this 5. Then integral from 0 to infinity 1 upon u square plus 25, we can write 5 square. Then what is the standard formula of this? 1 minute. According to this, we have to write the standard formula here. What is that? Integral from 1 upon x square plus a square dx. The standard formula for this is 1 by a tan inverse of x by a. Actually, this is the standard formula which we have to use. Already we have taken this formula here. Here is also 1 by a tan inverse of x by a. इथं विसरला होता पा. I have mistakenly 1 by a tan inverse of x by a. So we can write this. Integral of 1 upon x square plus a square dx is 1 by a tan inverse of x by a. So 1 upon u square plus 5 square du, which gives 1 by a means 5 tan inverse of u by 5. So p to infinity. Now keep the upper limit. Upper limit is infinity. Means tan inverse of infinity by 5 means pi by 2 minus tan inverse of p by 5. So pi by 2 minus tan inverse p by 5. So cot inverse of p by 5. Cot inverse of p by 5. So again we can write this as a cot inverse p by 5 means tan inverse of 5 by p. Suppose this is equation number 1. Now by the first shifting property, hereafter we have to use, this is Laplace transformation of sine phi u t divided by t, but we have to calculate sine e raised to, what is that? E raised to 3t. So by using a first shifting property, Laplace transformation of e raised to a t f of t, then capital F of p minus a. That means same, we have to use this shifting property for this problem. Laplace transformation of e raised to 3t sine phi u t divided by t is equals to tan inverse of p divided by 5 divided by p minus 3. Okay, in this way we can write the solution. Now next, prove that, our next problem is prove that Laplace transformation of e raised to minus at minus e raised to minus bt divided by t, which is equals to log of p plus b divided by p plus a. This is our aim. Prove. This is our aim. This is our problem. Now here Laplace transformation of e raised to minus at minus e raised to minus bt, which is equals to Laplace transformation of e raised to minus at minus Laplace transformation of e raised to minus bt. Okay, because Laplace transformation is the linear transformation, so we can separate in the addition and subtraction. So what now? Laplace transformation of e raised to minus at according to the standard form 1 divided by p plus a minus Laplace transformation of e raised to minus bt is 1 divided by p plus b. Suppose this is, again, suppose this is capital F of p. Sorry, capital F of p. Now our aim is to find out Laplace transformation of e raised to minus at minus e raised to minus bt divided by t, which is equals to integral from 0 to infinity capital F of u du capital F of u du. So integral from 0 to infinity 1 upon p plus a means u plus a minus, here we have to write 1 minute, this minus 1 upon u plus b, 1 upon u plus b. So we can write again, see this, integration of 1 upon u plus a with respect to u is log of u plus a minus log of u plus b. So log of u plus a divided by u plus b over the limit p to infinity. Again same, for the upper integral, upper limit infinity, we already calculated its value is 0. So minus log of lower limit put in place of u as a p plus a divided by p plus b means minus log of p plus a divided by p plus b. So remove this minus, then we get the reciprocal in the logarithmic function log of p plus b divided by p plus a and hence proved. ओके, अशा पद्धतीने हा फॉर्म्युला प्रूव्ह होतो. ठीक आहे. नाउ नेक्स्ट example is if capital F of p denotes the Laplace transformation of small f of p. See this. If capital F of p denotes the Laplace transformation of small f of t, then show that Laplace transformation of e raised to minus b by a t into f of t by a, which is equals to a into capital F of ap plus b, where a is greater than 0, for a is greater than 0. Now see this, given that actually in this statement we have given Laplace transformation of f of t is equals to capital F of p. Now we have Laplace transform, this is another theorem. Already we have proved, this is the statement of theorem. We have Laplace transformation of t by a, which is equals to a into capital F of ap. Capital F of ap. By the first shifting theorem, now we have to use the first shifting theorem. Laplace transformation of e raised to minus b by a. What is the first shifting theorem? See this, I am going to write here. First shifting theorem, Laplace transformation of e raised to at into f of t, small f of t, which is equals to capital F of p minus a. See this is the first shifting theorem. Here capital F is a Laplace transformation of small f. So we have to use the first shifting theorem here. Keep this a as it is, capital F as it is, a as it is. In place of p, we have to write p minus a. A means here minus b by a. Here actually a means the index, e raised to at. So a means minus b by a. So p minus b by a means p plus b by a. Now multiply in the bracket, multiply by a in the bracket, so ap plus b. This is the required answer, this is the required result. Okay. Next we have to calculate the next problem. Given that, now here already we have given Laplace transformation of sin t divided by t, which is equals to tan inverse of 1 by p. Given that Laplace transformation of sin t divided by t, which is equals to tan inverse of 1 by p, then find Laplace transformation of sin at divided by t. See this, given that Laplace transformation of, see here what we have given, Laplace transformation of Laplace transformation of sin t divided by t is equals to tan inverse of 1 upon p, or we have proved this statement. Now we have to calculate Laplace transformation of sin at divided by t. So Laplace transformation of, now sin at, keep this sin at as it is, in the denominator there is only t. So divide by a, multiply by a, then we in the denominator we will get sine a t. So take this a out of this Laplace transform. So a into Laplace transform of sine a t divided by a t. Sine a t divided by a t. So its Laplace transform is 1 upon a sine tan inverse of, if see this, we know that this is the definition. This theorem we have to use. Laplace transformation of f of a t is equals to 1 by a capital F of p by a. So we can write Laplace transformation of f of a t. F of a t. So here is sine, this is f of t, but this is f of a t. So Laplace transformation of f of a t, which is equals to, according to this theorem, we have to write 1 by a capital F of p by a, means tan inverse of p by a. In place of p, we have to write p by a. So a will be get cancelled, tan inverse of a divided by p. Thus we get the result, Laplace transformation of sine a t divided by t is tan inverse of a divided by p. समजलं का रे सर्वांना? काय अडचण आहे का विचारा स्टुडंट्स. If you have any doubt, then you can ask me. Okay? विचारा रे, तुम्हाला येतं का? काय अडचण असेल तर विचारा. नाही ना? ठीक आहे. नाउ यू हॅव टू सॉल्व दीज होमवर्क्स. आता काय करा, हे होमवर्क तुम्ही सॉल्व करा. होमवर्क लिहून घ्या सर्वच्या सर्वांनी. हे प्रॉब्लेम सर्वांनी सोडवणं गरजेचं आहे. इथं मात्र हिंट आहे. ऍक्च्युअली यू हॅव टू सॉल्व ऑल दीज प्रॉब्लेम्स. हिअर इज अ हिंट. Laplace transformation of 5t e raised to 3t into sine square. So first of all you have to write sine square means 1 minus cos, sine square theta means 1 minus cos 2 theta divided by 2. By using that formula you have to again solve. Okay? ठीक आहे. तर इथं आपण थांबू. काय अडचण आली तरी तुम्ही मला विचारू शकता, कॉलेजमध्ये विचारू शकता. Now we shall stop here. Good night.